Okay, so let us talk about semi-supervised learning. The previous section we covered data set augmentation. See, it's very simple thing. Okay, we covered this. I forgot to mention. I mean, highlight it. So we have covered data set augmentation. Now we'll move to semi-supervised learning. It's a very easy learning. See, semi-supervised learning is what? It is a combination of supervised and unsupervised learning, where you have some labeled data but remaining unlabeled data. See, what is the label? See, suppose Y is a label. Okay, suppose you have a image of a man, in a shorts having a bat not bat tennis racket. Okay, so now it is unlabeled data. Suppose we don't know what he is doing, but in labeled data we'll be having a tag or label saying that it is a sports picture, so we can easily classify that this X image is a sports image, or X audio is a sports related, or commentary is related to sports, right? Or you can take commentary itself as a label. So it is a labeled data, unlabeled data. To learn P, Y or X, or predict Y from X. So predict Y from X, what? If you have multiple X images, okay, you have multiple images, sample images. From that sample images, you have to, classify what kind of label it is. Like, is it related to commentary, related to sports, or food? So suppose you have multiple food images, you can easily predict that Y is nothing but food. Category is food. Okay, if you go deeper, you can say chocolate. You can differentiate in flavors. You can differentiate in type, whether it is a molten thing, pastry, or cake, or cheese, or something like that. Okay, that's what it is. Real one analogy: you learn English by watching many videos, unlabeled exposure. Like TV series, doing some guide grammar exercise with answers. Textbooks and all that is labeled. Both together improves learning. You can do this as caption with video series. You are turning on the caption. Okay, deep learning view. Most important explanation. In deep learning, semi-supervised learning usually means learning a representation. That is, h is equals to f of x. F of x is a function, h is equals to f of x. Goal. Examples from the same class should have similar representations clustered together. In the sense what? For example, multiple images of a pastry or a cake. So see, they have to represent the same thing, that is food category or pastry category. Multiple images. If we have high fried cook like chicken, and okay, will be a little vegetarian, because few vegetarian people don't like about talking non-veg. So like vegetables, so many green things, stuff, broccoli, spinach, etc. All these things should present what? Vegetable or green vegetable. Very particular if you talk green veggies, like that. Unsupervised learning helps group or cluster the example. So you'll, based on similarity, you will group or cluster them, and then a simple classifier in that representation space generalizes better. Classification, based on features and all, labeling them. So classic example, using PCA as pre-processing before classification, all but important. Okay, so we have generative plus discriminative shared parameters. Instead of separate unsupervised plus supervised models, we can build a model where a generative model of P of X, this is what, unlabeled or labeled, shares parameter with a discriminative model, P of Y or X. Okay, then total training mixes two objectives. This both supervised loss is equals to minus log of P of Y or X, unsupervised generative loss minus. So you have to apply for this, and then you have to apply for this. Okay, it's very simple. You see generative model, this or this or is what, this one line. So Y or X, it becomes like that. In supervised, minus log of this. In unsupervised, minus log of this, and this comes in the bracket. Or very simple, right? This acts like a prior belief that the structure of P of X is connected to P of Y or X. Okay, quick summary table. So we saw in the last video data set augmentation. What it does, creates anything data to reduce generalization error. Example, shift, rotate images and adding the noise. Caution, don't change the class label. OCR, avoiding flipping B or D or rotating 6 or 9. Semi-supervised learning, use labeled plus unlabeled data, learn H equals to F of X, then classify. Representation learning, same class sample should cluster in, in representation space. PCA or features, then linear classifier. That completes the topic and almost half of the module of 3, and then we'll move in the next topic. We'll move to module 4. Okay, then I will move to module 5, and then we'll complete with module 2. We'll see in the next video. Bye bye. Yeah, before we move, okay, so it's pointless to tell now, but I have to talk about this AI platform, which was built by someone I know, and I have it was literally helpful for me to generate notes and all. This all takes only 2 credits. If you want actual high level of thing, AI slides, any topic you give about the you have to give a description. It creates a slides with limited image generation. You have based on feature, Plans is also very friendly, like 400 per month, like very affordable. And it has, you can see all the features over here. You have so many solver example. It's all based on, for daily usage and all. So you can, if you are using this AI, you can learn every day, and you can, perform well in your examinations. You will be pre-prepared. So you don't have to worry about examinations anymore.